Hi everyone. Today we are going to look at hyperbolas. We've discussed about them, and now we are going to try to solve some problems relating to hyperbolas. We've discussed the benefits of hyperbolas. We did mention that with the help of hyperbolas, engineers are able to design things that are specifically used by our eyes. Things like binoculars, telescope, monitors, contact lenses. These are all designed with the help of understanding what hyperbolas are. So here we have a question here. It says find the center, the vertices, the foci, and sketch the hyperbola x squared divided by 25 minus y squared divided by 16. So we already derived the formula of a hyperbola the last time. I will just state it here again. It says x squared all over a squared minus y squared all over b squared equals 1. This is one of the formulas. There's another one that says y squared all over a squared minus x squared all over b squared equals 1. It's always equals to 1. Can you spot the difference? This starts with x, this starts with y. And what is the difference? If you are plotting or you want to sketch the graph for this one, the hyperbolas, they will lie along the x-axis. They open up on the left and right side of the x-axis when you have a positive a with the x. Here you can see now it's y with a, not x with a again, y with a. So what this one tells us, the hyperbola will open up along the y-axis, up and down. It opens up and down along the y-axis. Here it opens sideways along the x-axis. We shall solve a problem relating to this, a problem relating to this, and a problem relating to the hyperbola when the center is not at 0, 0. So now let's start solving the problem. This is what we are asked to do. This one, so we ignore this for now. It says x squared divided by 25 minus y squared divided by 16 equals 1. We are asked to find the center of the hyperbola. The first question here, center, vertices, foci, and then finally we'll sketch the hyperbola. So how do you find the center? When you draw your hyperbola, this is the center of the graph. X, y. This is center. At this point, x is 0, y is 0. So this is the center of the graph. If this is the focus, this is again another focus, and this is the vertex. This is the vertex here. The vertex is the turning points of the hyperbola. It's maximum turning point here. This is V1, V2, F1, F2, vertex 1, vertex 2, focus 1, focus 2. Right? So you can see this center line divides the two hyperbolas in the middle. This one on this side, this one on this side. This is right in the middle of the foci, if you want, or foci, and how they call it. Right? So this is what it means when it's at the center. Suppose now this is not at the center. This hyperbola is not at the center. Suppose it's somewhere here. It's somehow here. Oh. It's not at the center again, it's not at the origin, but it still got its center because they are always separated equally. The two hyperbolas are always separated equally, but now they are not at the center of the graph. So in that case, we've moved on the x-axis by h and on the y-axis by k. That's the movement we have made. It's going plus or minus. In this case, it's minus. You see, it's plus. Sorry, it's going down. It's plus. Yeah. So when you want to represent this graphically, analytically, it's going to be like x minus h all squared all over a squared minus y minus k all over b squared equals 1. When the hyperbola is not at the origin, it has this kind of rule. When it has the origin, you find out this is 0, and then you get x squared all over a squared minus y squared all over b squared equals 1. When this h and k are 0, it means the hyperbola is sitting here. So that answers our first question. Yeah? It says, the first question says, find the center of hyperbola. So because there is nothing here, x minus 0 is just x, y minus 0 is just y. Yeah? So the center, C-E-N-T-R-E, by just looking at this hyperbola, the center is 0, 0. It's sitting right at the center of the Cartesian coordinate, xy coordinate. So they say find the vertices. For us to be able to calculate the vertices, we need to find the number underneath the x squared. The x squared, that gives you the vertices. And so we need to find a. We have a squared equals 25. A squared 25. This is our equation we are given. This is the normal equation of a hyperbola. A equals 25. A squared equals 25. Then a, it means, is plus or minus the square root of 25. So a therefore is plus or minus 5. Because a is a perfect square. So you get plus or minus. So then the vertices are at minus 5, 0 and 5, 0. Plus or minus. One is sitting at minus 5, 0 and 5, 0. We shall, when we do the graph, sketch the graph, you will see. Now let's find b. B squared. B squared is 16. So what is b? B then is plus or minus the square root of 16. So this is plus or minus 4. Let's keep it aside. Let's b here equals plus or minus 4. Let's keep it here. We shall use it later on. So let me use, I'll be changing my markers because some are not writing properly. So now let's find the full side. the foci, we have a formula here that says c squared equals a squared plus b squared. This is at the foci. So this is now a squared, is 25 plus b squared is 16. So this is 41. C squared equals 41. You want c. So c is the root of 41. The root of 41, let me use my calculator. .4. This is 6.4. So therefore, the foci sits at minus 0 minus 6.4, 0 and 6.4, 0. One is negative, one is positive, because you have left and right hyperbola. Opens on the left side and also opens on the right hand side. So that's why you have two foci. So what follows? And now they ask us to sketch the hyperbola. And the sketching side. Let me use red marker so that you can see properly. We now want to sketch the hyperbola. So we already mentioned that it's along the x-axis because of we have x, a here is positive on the x. So we'll draw here, draw a y-axis. This is x, this is y. But before you sketch a hyperbola, you must be able to find the asymptote equation. You must be able to find those equations. It's two of them. You are given those equations, excuse me. Say y is equals to plus or minus b all over a x. This is a line, it's a straight line. The gradient b over a x plus or minus. It's two equations. One is y equals b all over a x, and the other one y equals minus b all over a x. That is what this one means, plus or minus. Two equations. One is negative, one is positive. Yeah. But if you can't remember these equations, say this formula in an examination, an environment, something like that, like you forget, you can't remember this. And when you do maths to this level, you are able to calculate the equation of a line. You know that. You can do that. So in case you forget this formula, you can still use your coordinate geometry to calculate the equation of a straight line. You can find it in case you forget this formula. So now let's graduate this line. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So here you have 1, 2, 3, 4, 5, 6, 7. This side is minus. All is minus. Minus 4, minus 5, minus 6, minus 7. And here again you have 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Why I stop at 4 here? Because this is the A will get from here, from the horizontal. The B will get on the vertical line. Our A, first the center is 0, 0. So we have it here. The vertices minus 5, 0. This is, so 1 is here, minus 5, let me use difference. That's my tell. Minus 5, 0. Excuse me. And the other one, 5, 0 plus 5, 0, we have negative, 0, 5, 0. And now our b, which we calculated before as plus or minus 4. For 4, this is 4 here, minus 4 here. So we have plus 4 and minus 4. So this is plus 4 and minus 4. So now let's draw. Let's try to join these 4 points, because these 4 points will now give us a rectangular hyperbola. And from that rectangular hyperbola, we can be able to draw our straight lines that give us the equation of the asymptotes. So let's join them together. We are trying to form a rectangle here, joining all these points. See that? This is what we get. We get this rectangle after we join this point. So the asymptote line passes through the middle and to the diagonals of this rectangle. So it's gonna go through here and through here. So this line here, the equation of this line is y equals b, which is 4 all over 5x. This is this line. And we'll draw another line here as well. It passes through the middle, diagonal line. So the rectangle is not straight, but you have the idea. So this one here is minus. This is y equals minus 4 all over 5x. So this is what I was saying. If you can't remember this formula, but as long as you are able to plot this line, you can find the equation of this line using coordinate geometry. You know the equation of the line is y equals mx plus c. At this, if you can do math to this level, you can calculate the equation of it. Let us don't go into that. So this is what you have. Now let's plot our hyperbola. This is the vertex. The vertex is the maximum turning point of a graph. All these conic graphs, when you are asked to find the vertex, is mostly the maximum turning points. So this is, and then don't forget, we have this line, we have this line, we have this line here, we have this line here, the asymptote line. So first, this is the maximum turning point. It's going to go like this, like this, like this, like this, and it's followed like a straight line. And again, it's going to go like this, and then it will follow this line straight. It will not touch it. That's why it's asymptote, but it will follow it. And this is your 6.4 before we have as the vertex, the four side 6.4. So this is your 6.4 here. This is the focus. And also your 6 minus 6.4 here, this is the focus. So again, this one, it will go like this, and then you follow like a straight line, like this, follow like a straight line. So this is how it opens up. So this is your hyperbola. Now, you're asked to sketch it. I hope you enjoyed the lesson. Thank you.